Hello, welcome everyone to another episode of the Virtual Ninja Show. My name is Heike and today I have Yong with me. Yong, I was waiting for you to join the show for such a long time and finally we made it. Please introduce yourself.
Thanks very much, Heike. My name is Yong Rhee, and I'm a product manager for Microsoft Defender for Endpoint, and I'm based out of Southern California. And I've been with the team for the last 2 years and 9 months, and I'm excited to be here.
Yes, but we know each other for much longer.
Oh, yes.
So, yeah, you were part of the CXE team. Now you're part of the PG team. So it's amazing to have you. And we are going to talk about a topic that customers might face, which is performance issues with Defender for Defender Antivirus. And you are my expert for that. So let's start. Like, what are typical cases where customers can, cause or like see high CPU?
Yeah. So there are different reasons for high CPU utilization, and a lot of times it's about how the application has been compiled or might be missing certificates, which makes us untrusted. There could be, even if the exe is signed, the modules loading in them, such as DLLs, might not be signed. There could be complex file formats, obfuscated scripts, which causes us to investigate more than a plain script.
So when you say invest makes us investigate more, which means you're talking us as the AV engine. So which means if a certificate is not signed or something, our AV will then scan the full file and go more into the details and not do a quick scan, which then causes to the higher CPU.
Yeah, so most of the malware out there are unsigned, which uh, has us scan those binaries more often. If the binary is signed and there's a trust root certificate on the box, that means that the company goes ahead and trusts the binary. So there's less likelihood for us to need to scan that. Um,
Mhm.
so there's less chance of higher CPU utilization for those.
Okay. Okay. Besides not signed files, what were some other common cases that you saw?
Yeah, the complex file formats are things like HTAs, um, which can be used for database, like files. So, customers may end up using them in ways that they weren't really, initially created for. So
Mhm.
what we do ask is if you're using any kind of files to act as a database, is to actually, move it to an actual database so
Mhm.
that, we don't end up scanning as much. And the other
Mhm.
things are, PowerShell scripts, for example. If you end up obfuscating so that folks are not able to read it, right? It causes us to go, hey, what's inside of that script? And causes us to go ahead and scan. We'll do an AMC scan in order to see what that PowerShell script is doing. So these different things could lead to higher CPU utilization during real-time protection.
Mhm. So these are all cases, Young, where you would see probably a spike, but it would go down again, I would assume, right? Because you would then. Mhm.
Yeah, so normally, when a process is launched, we'll go ahead and do the initial scan, unless there are indicators certificate allow, or like indicators for file hash allow, or if they're excluded in the exclusion list, right? But these, spikes should, tend to be from 1 second to at most like 10 seconds for us to do the scan, right? Now, when things end up impacting the end users, is that when an application or a script is, doing something that causes us to continue monitoring it, so that you'll see this continuous, CPU utilization.
Mhm.
An
Okay.
example, yeah, is if you at some point in time, one of the hardware vendors had a keyboard driver that was logging every keystroke because they, left the uh, debug on for that keyboard driver, right?
I
So
know.
obviously, we would be scanning, and the customers would call in and go, "Hey, we're having high utilization with your
Yeah.
product," but in reality, was there was something happening on the system that was unusual, which made us to do that scan, right?
Yeah, I know it's not funny, but it's like, wow, someone is typing crazy and the CPU goes up, and someone is slowing down and the CPU slows down.
Right, right.
Um, so, okay, those are, of course, issues that can happen but shouldn't happen too often. And then I see there's also configuration issues. What could this be?
Yeah. So the different configuration issues could be where, for example, if you're creating a VDI, environment, like non-persistent VDI environment, where you end up sealing the image before the MDV cache maintenance ends up finishing. What that cache maintenance does is goes ahead and scans for the binaries that are on the system,
Hmm.
and creates file hashes, and we end up caching that information to optimize performance. Now,
Hmm.
if the image is sealed, right? So before this is finished, imagine that every single time a new VM ends up launching, it's going to have to go ahead and parse through all the files on the system, which will use CPU utilization in order for that file cache information to be cached. So when you compound that with 50 VMs running at the same time, being launched at the same time at 8 a.m. when end users are logging in, that's going to impact the host VM. So not letting this finish, is one of the common reasons for like high CPU utilizations
Hmm.
on VDI
Hmm.
systems. And the other thing that we have noticed is that, when you're adding path exclusions, it's easy for folks to fat finger the path. So, putting the wrong information is like a path that may not exist, which causes us to go ahead and, go through
Search for it.
looking for, yeah, searching for that path on the system. If it's not there, right, we'll continue until we come to an end, which you will use up more CPU utilization. So it's important to run the npcmd run to check the exclusions and make sure that the exclusions are properly set.
So I know that you're going to share links later at the end, but there is something like best practices, right? How to
Yes,
make sure your configuration is properly set, avoid these mistakes, and so on.
correct.
Mm. So, Young, how do you identify high CPU troublemakers?
Yeah, so very good questions. Identifying contributing components. So we have different type of scans in Microsoft Defender for Antivirus, and depending on what it is, it could be real-time protection, it could be scheduled scans, it could be catch-up scans or on-demand scans, or even process scans. So we could talk about these different ones, right? Real-time protection is the on axis. So as soon as something is downloaded or open, we'll go ahead and scan those. The schedule scans is, when an administrator goes ahead and sets up a scan that could be daily or it could be weekly. So the dailies are quick scans. The weekly can be set as um, quick scans or full scans. And obviously, the full scans will take longer in order to finish scanning. So the CPU utilization will be, higher during that time. So it's important for administrators when they're setting up the schedule scans to set it when their end users are least impacted by them. For example, Wednesdays is normally when everyone is in the office. So setting up Wednesdays at lunchtime for quick scans is probably a good idea. For the full scans, you may want to kick it off at 5 p.m. when people start heading off, as long as the machines are not turned off, so that the full scans are done by the next day.
Yeah,
Um,
makes sense.
in case if the laptops or tablets end up getting closed, and those schedule scans are missed, but the second time that is missed, we have this catch-up scan that ends up running in order to catch up against the missed scans. For catch-up scans is when there are at least two scheduled scans that have been missed, and most of the times it's because it's a laptop or tablet where they go in uh, energy saving mode, such as sleep or hibernate, or if the systems are run out of battery, or if the systems are shut down, right? Um, for the on-demand scans, they could be done remotely by SOC analysts. If they find something suspicious that's happening, they could kick off a quick scan or full scan from the Microsoft Defender for Endpoint portal, or an end user is able to go ahead and kick off an on-demand scan on their local systems through the UI also. And then lastly, there's an option when the security intelligence updates are updated to run a process scan right after that update occurs on the system. So that could also make it look like a quick scan is running, but it's in reality a process scan.
Wow, okay. And then I see the last one here is conflict with maybe a third-party software that's also running.
Yeah, so there are, obviously environments can have different set of security products, such as something that elevates permissions for the end users to go from regular users to local administrators. For those, it's beneficial for customers to go ahead and add AV and EDR exclusions for those third-party security products under Microsoft Defender Antivirus. But also, if they have Microsoft Defender for Endpoint, it's ideal for them to add it. And if those products do have an exclusion for AV and EDR, likewise for them to add R binaries so that they don't end up scanning the same type of I/O and stepping on each other.
Yeah. Okay, thank you. So, Yong, now that we know there is various reasons, how can someone troubleshoot it?
Yes, so we have different tool sets to troubleshoot high CPU utilizations. For a good amount of time, we had tools like sysinternals, Process Monitor, and the Windows Performance Recorder. If we look at it, the toughest one for IT administrators, security administrators to ramp up on is the Windows Performance Recorder. So the Windows Performance Recorder is fairly advanced, which requires a bit of learning in order to really grasp the tool set. It's fairly advanced, as in being able to not only troubleshoot CPU utilization, you're able to troubleshoot hangs, you're able to troubleshoot memory leaks, disk I/O, file I/O issues, and on top of that, the mini filter latencies that could be occurring. And there's other tools like Process Monitor, which the entry to use it is a little bit easier. So Procmon, which allows you to profile the disk I/O, the registry, a little bit of the network in order to see what might be happening. Now, because Procmon and WPR, are pretty challenging for most, we went ahead and created a tool called Microsoft Defender Performance Analyzer, which makes troubleshooting high CPU utilization on Microsoft Defender Antivirus that much easier. It saves administrators time and makes it easy to parse that data set.
Okay, so the other tools are probably part of sysinternals, I would assume. And then the Microsoft Defender Performance Analyzer is something they just go and download it, or does it come with the Defender already when you install it, or?
Yeah, very good question. So Process Monitor is a sysinternal tools. Windows Performance Recorder is a part of the Windows SDK or the Windows ADK toolkit. So you have to download these separately. The great news about the Microsoft Defender Antivirus Performance Analyzer is that it goes ahead and is shipped with the AV. So it's right there for you
Perfect.
to utilize. You don't have to download anything. It's built in. So you don't have to go through the change control process to install something on the box.
Perfect. And I think you can show it to us now.
Yes, in this example, an end user was reporting that Microsoft Defender AV was spiking CPU when launching PowerPoint. And in order to go ahead and collect that data set, we could go ahead and go to this page right here, the Performance Analyzer for Microsoft Defender Antivirus. We're able to see the instructions on how to collect the data set. So collecting data is dropping down to a PowerShell commandlet, typing in new-mp performance recording space dash record to, and then passing a name. In this case, we could just pass it to recording.etl and collect this data set for 3 to 5 minutes is usually sufficient in order to go ahead and get enough samples to go ahead and analyze the data set. So whenever you're done collecting data, you want to go ahead and press enter to stop, or you could press Control C to cancel recording and start the recording again.
And then you have a bunch of data that you now need to analyze?
Yeah, so after that, in this demo, if an end user is reporting high CPU utilizations, we're able to go ahead and collect the data using new-mp performance recording record to recording.etl.
But this is Yong right now in just a regular PowerShell, right? This is not the tool yet. Okay, perfect.
Yeah, this is just PowerShell. So the tool itself has a PowerShell commandlet, and the commandlet is called new-mp performance recording.
Got it.
And anytime that you want to collect any traces when you're having high CPU utilization, you do want to close as many applications as possible that are not needed for the report to occur. Okay. And then the other tip that we have here is to not collect a process monitor simultaneously when you're collecting a Microsoft Defender Antivirus Performance Analyzer recording. So once you go ahead and press enter, you want to go ahead and collect for 3 to 5 minutes. Once the data is collected, in order to analyze the data set, in this example, we're going to be going over where the end user had reported that PowerPoint.exe was causing high CPU utilization. So I'm going to go ahead and run this command right here, get-mp performance space dash path space c colon /temp recording.etl space dash top processes 3. And we can see here that for the 110 times that we went ahead and sampled, one of those had a max duration of 129 milliseconds, and it just happens to be PowerPoint executable. So next, what we want to do is what's happening for the scan within PowerPoint. So we're going to go ahead and run this other command, which is get-mp performance report space dash path c colon /temp recording.etl dash top scans 3. And in here, we're able to see that the max duration of 129 milliseconds occurred because of a real-time scan against the duration of this one binary, right? Which is in the temp folder for the user profile, and it's called PowerPoint labs.dll. So this right here looks like it's taking 129 milliseconds to go ahead and load. And the same thing where this binary right here is taking another 124 milliseconds to load. And then we have the matapps.metro.dll that took 89 milliseconds. Now, the thing that we want to see is there like a hot path?
So this isn't yet enough evidence for you that these three DLLs are pretty much disturbing. Yeah.
Right. So this gives a guidance that there is something related to those DLLs that
Mhm.
it's happening that is causing us to do a real-time scan, but it doesn't tell us exactly why yet. So we have a few more commands that we could go and run.
Perfect.
The next one is to just get the top path. In this case, we're getting the three top paths. So we're going to go ahead and run this command right here. And when I'm looking at the top path, says C users admins, right? So which is pretty much what we saw where that DLL was, and then another one was like C Windows assembly prefetch or System32 program data, and the other one is like under program data Microsoft. So there's really not something that jumps out in this case. So we're going to go ahead and run one more command, which is the overview. So if I go ahead and run the overview switch, in here, it pretty much tells us why
Ah.
there was a higher CPU utilization in PowerPoint. So
Mhm.
the nice thing about it is it tells us that the DLL in question is not trusted, which means one thing, right? Is that the DLL more than likely is not signed, as in there's no certificate for that DLL. Even though PowerPoint and the Microsoft binaries do have a certificate, they're signed, they're trusted by us, because this module is being added as a PowerPoint add-in, and
Mhm.
PowerPoint.exe is loading this module. Because this module is not signed, we're tainting the whole PowerPoint executable, because it
Mhm.
makes it untrusted, because this DLL could be injecting code, it could be doing different things that are malicious. So it makes us go ahead and scan the whole process and the binaries that go with it.
And not trusted can also mean it is signed, but not with a trusted authority or the certificate expired or something, right? So
It
like
could
to
be.
point people in the right direction,
Mhm.
not trusted, to make sure there are certs.
Yeah, I mean, one of the things that we highly recommend is to make sure the certificate revocation list is working, that communication is working,
Mhm.
because what could happen is uh, one of these, ISVs could end up getting, hacked, and you could have malicious, threat actors adding code, right, and go ahead and publishing new versions, right, to where
Mm.
customers end up downloading, installing.
Yeah.
So in order to prevent those malicious binaries from working, once the ISV goes, hey, we got something suspicious going on, we need to go ahead and revoke those certificates. That is done automatically, right? So at that
Mhm.
point, those certificates are no longer trusted until a new, they're able to review their code and go ahead and publish, sanitized version of their code that is with the new certificate.
Cool, thank you. So now in this case, you would go and uninstall that plugin or whatever it is, and then
Yeah, so obviously the workarounds that you're trying to point out here is, yeah, for short term, they could try uninstalling the plugin and see if the problem goes away, right? Or they could also go ahead and do this, right? Follow up with the ISV and see if they are able to sign the binaries
yeah.
and have a trusted, root certificate on the machines. Or as a workaround, what customers could do is uh, if these uh, if they have an internal PKI, they could go ahead and sign those binaries, especially if they're
If they trust them, yes, of course,
internal
yeah.
apps. They could sign them with the internal PKI and then use indicator certificates to go ahead and trust those and so that Defender Antivirus goes ahead and trusts those binaries that are signed with those certificates. So there's less of scans that happen against them, right? So that is, the DL workaround. But let's say that to set up the signing, the certificate, it's going to take a month or two. What customers could do is go ahead and add exclusions uh, to the path. But when we look at this, right, it's not ideal to have an exclusion
No,
under the app
on that
data
temp
local
folder.
temp folder,
Yeah.
right? So that's like worst case scenario where they need relief, and either the ISV or internal devs, need time, but it's not the preferred method of work around this.
This was great, Jon. This is awesome.
Thank you. So I have another demo. In this case, is a PowerShell script. I showed you all how to go ahead and run a command one by one. But in this example, what you could do is go ahead and add all those switches together and just run it at once. In this case, customer is reporting that their end users are seeing high CPU utilization by msmp eng.exe, which is the primary service for Microsoft Defender Antivirus. And they're trying to figure out what's happening. So we're going to go ahead and run get-mp performance report -path, and then the ETL file that was collected, -top processes, -top scans, and then -top files per process, and then top paths and overview. Here, we're going to get a lot of information, but that's okay, right? So we'll start from the top. So in this case, in the overview, it doesn't really tell us anything that might be happening. In the top processes, we're able to see that it's related to PowerShell because the binary that we see is PowerShell, and the max duration is 159 milliseconds, and there were 1,770 samples while this trace was going. Now, unfortunately, right, it doesn't tell us what PowerShell script is leading to this, because whatever it is running in memory. So there's that scan going on in memory, and we can see that the max duration here is related to this memory scan,
This one.
right, that occurred. And so again, we see PowerShell again doesn't give us much information, but the other thing here that we see is under C Windows Assembly native images. One of the things that we end up noticing is the ctemp start.cmd that looks like it's running. So that's quite interesting, right? So as an administrator, I would go ahead and take a look to see what's in that ctemp start.cmd. And one of the things that customers could do is add a path and process exclusion against that, if that's a legit, bash script that is calling PowerShell. That's one of the workarounds that they could do.
But if they would make an exclusion for this one, does this exclusion then also include the files that were called through the exclusion? You know what I mean?
That's a good question. So the other thing that we could do, because if we're looking at the paths, there's really not much information about what is leading to the higher CPU utilization. So we still don't know what the PowerShell script is, right? So what we can do is change this top file processes per process to 5. And I'm going to clear the screen before I run it. And here we go. Now, if I go back, all right, so in here, what we do see is this history.ps1, right? So what it looks like it's happening is that start.cmd that we saw earlier um, is calling into the
Mhm.
history.ps1. And at this point, what the administrator could do is, check to see, what code is on history.ps1, right? And they could try, optimizing that code. The other thing that they could do is to try adding exclusions, but ideally they would change their code so that it doesn't, run from the temp folder. It would be run from a, static location.
Proper.
Yeah,
Yes.
where they could add, you know, file exclusions or
Yeah.
folder
Yeah.
exclusions to it.
Yeah, you don't want to exclude the whole temp folder. There's everything goes in
Absolutely.
there.
Yeah, that's
Yeah. Yeah.
definitely the worst thing to do, right? Because then at that
Mm.
point, anything that is downloaded through browsers, anything that's downloaded through emails, those are all going to be excluded. So definitely, it's one of our, file paths to not exclude for customers.
But what leads you to that history.ps1? Because we still have that PS that PowerShell file in memory running doing something.
Right, right. So in this case, what we want to do is open up Start and see what's inside of it. So we're gonna
Yes.
open this up in Notepad. So we can see that there's a loop that's happening where PowerShell is opening this unsigned PowerShell file, history.ps, that is sitting in the user profile,
Mhm.
and it's looping, right? So it goes to start over and over again and causing the high utilization.
Why is someone doing that?
In this case, it was an administrator that not optimized the logic for what they were trying to do for their PowerShell
Mhm.
scripts.
Okay.
Many things that they could end up doing to remediate this, and obviously, it'd be ideal for them not to run the PowerShell script from the user profiles temp directory. And also, they're able to sign the PowerShell script to. That's something that they could do to make sure that only PowerShell scripts that are signed will end up running in their environment. But in this case, they just would need to optimize this code so that it doesn't loop over and over again. So that was the end of sample two, where it's up to the IT administrator to find a way of optimizing their batch file in order to for the PowerShell to not loop over and over again, and ideally move it to a different folder than the user temp profile.
So Young, I mean, you are an expert and you're like, yeah, dealing with this for such a long time. How does someone get started?
So we do have many different tools and books that are available, but here in references, we do have a whole page dedicated for Microsoft Defender Antivirus Performance Troubleshooting, aka.ms/MDAV perf. And there are books to ramp up on sysinternals.
I know, but ramp up sys internal or like Windows internals, it's like this. And it
Yeah,
put me to sleep many
uh,
times because it's,
absolutely. It's
ay,
uh,
ay,
yeah. So
ay.
there's another book called Windows Performance Analysis Field Guide by Clint Huffman that helps IT administrators, security administrators through common reasons for high CPU utilizations in their systems.
Cool.
And the Windows internal book is for reference purposes. So really quickly, we're going to go to that MDAV perf browser. So it's going to end up landing you here under troubleshooting performance issues related to real-time protection. And we go ahead and go into details about the common reasons for high CPU utilizations by Microsoft Defender Antivirus. And then you can see here pretty much the topics that we talked about are here. And then to help determine which components might be contributing to higher CPU utilization, if it's real-time protection, we have like solutions here. For schedule scanning, we have guidance. And then scan after a security times update, like what you could do to improve performance regarding conflicts with other security software, what you could do, and then scanning a large number of files or folders. So, one of the other common things that could happen is if you have low bandwidth, high latency, where you're connected to VPN, but your whole user profile is being synchronized via
Oh,
offline
yeah.
files or OneDrive,
Mhm.
and you have a 4.1 gig ISO or VHD sitting on your desktop. It's going to go ahead
Oh,
and synchronize that, right? And it has to scan to see what's on there. So if you don't need those ISOs,
always clean your desktop, guys. I tell you, always clean your desktop.
yes, move it to a folder where that is not synchronized, or maybe not
Yeah.
not sitting on a network share. And we go over the different tool sets. And the great thing about these is that we have an easy way of collecting Procmon and the Windows Performance Recorder via the Microsoft Defender Diagnostic toolset, which in our documentation, we have the instructions on how to collect that. So these documents have been updated recently.
Good. So I think, Yong, this was a good conclusion. So people have some resources they can go and look at and learn. And hopefully they don't have any high CPU issues. But if they're able to find out what is causing it. And yeah, Yong, thank you so much for being my expert on today's episode. I really enjoyed it, and I hope maybe at some point I will get you back with a different topic. Thank you, and everyone else there. See you soon.